Good morning, guys. So what we're going to be working on today is we're going to be working on 5.3c using a calculator to solve trig equations. So just keep a note here that we've already learned how to do this a couple of times. It's just more of a review to get some extra practice in. So the first thing I want you to do is I want you to pause the video and see if you can isolate x. And I want you to see if you can isolate x originally, not using your calculator. So see if you can isolate x, get to that step before you take any inverses. See if you can get everything in terms of one trig identity. Okay, so hopefully that was enough time for you to go and pause the video and try this. The first thing that I might want to do here is I want to get everything in terms of one variable. Well, cotangent squared x is the same thing as cosecant squared x minus 1. That's a Pythagorean identity. So I'm going to rewrite this. This is going to be 2 times cosecant squared x minus 1. And then we're going to say plus whatever's left, plus 3 cosecant x. And I'm also going to move the 1 over. I'll move it to minus 1. All right, so if I go ahead and use distributive property a little bit, I get 2 cosecant squared x minus 2 plus 3 cosecant of x minus 1 is equal to 0. So what I have is 2 cosecant squared x plus 3 cosecant of x, what looks like minus 3 is equal to 0. All right, so at this point, I probably don't know how to solve this unless I use quadratic formula. So just for the sake of teaching you quadratic formula, I'm going to go ahead and use the quadratic formula to solve this. So if I think about that song, it goes, I just woke up so my voice is a little bit cracky, but it goes x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So I'm going to go write that. So x equals negative b plus or minus square root of b squared minus 4ac. I really hope I embarrassed you guys this morning. All over 2a, I embarrassed myself. So what we're going to do is we're going to interpret b as being, if I line this up from highest exponent to lowest exponent, b is this coefficient here. So this is b. And a is this coefficient here. It's the first coefficient on the highest exponent. So that's a. And c is the lowest coefficient. In fact, it's going to be the constant. So c is the constant. All right, let's go ahead and plug this in. So x is equal to negative b, that's negative 2, plus or minus the square root of b squared, which is 4, minus 4 times a. I'm sorry. I'm not writing the right thing here. Sorry. Start that over. All right, x is equal to negative b. Sorry, negative b is negative 3. Plus or minus the square root of b squared, which is 9, minus 4 times a, which is 2, times c, which is negative 3, all over 2a. So that's going to be 2 times negative 3. So if I simplify this, I get negative 3 plus or minus the square root of 9 minus 4 times 2 is 8 and 2 times 3 is 24, but it's a negative, so plus 24. Plus 24. All over negative 6. So x is going to equal negative 3 plus or minus square root of 33 all over 2a. Did I do a wrong again? All over 2a. Sorry, let me take a pause real quick. I'm sorry, guys. So once again, I am apparently not the queen of the quadratic formula, only singing it cringily. All over 2a, once again, a is not 3, it's 2. I try to do colors here and still confuse myself, so that's 2. All right, so all over 4. So this right here is technically how I could get the solution manually. I'm going to talk about how in the world can I get this solution using my calculator. So how do I get this solution using my calculator? I'm going to show you 2 different methods. Number 1, I could get this solution of what x is equal to. And remember that x in this instance is really what cosecant is. So I know cosecant of x is equal to 2 solutions. It's equal to 3 plus the square root of 33 all over 4. And it's also equal to 3 minus the square root of 33 all over 4. To get that another way using my calculator, in my calculator, I could plug in this. 2x squared plus 3x minus 3 and see what I get. So let me show you how to solve that. So in my calculator, I'm going to clear this out. I'm going to put in 2x squared plus 3x minus 3. We're going to see where that crosses the x-axis. I'm going to actually zoom standard. There we go. All right, so I'm going to press second trace, and I'm actually, just for time's sake, I'm actually just going to pause this for a minute just so that I can just get the solutions quickly. Okay, so I got the first solution. I'm going to go ahead and show you how to get the second solution. What I'm going to do here, you're going to press second trace, which I realize actually now you can't see this on your calculator, but you are going to click second trace 0. You're going to go left bound and right bound of the value that you want. Press enter, 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 and you will get your solution. So the second solution here, which I'm just going to screenshot in, is going to look like this. The second solution here is going to look like this. All right, so these are the two values, and they're actually equal to whatever I got from quadratic formula. And unfortunately for us, that means we're not done. What I really have at this point is that cosecant of x is equal to negative 2.186, and cosecant of x is equal to 0.686. So if I think about what this means, cosecant is a y value. So if I were to think about what this means on my unit circle and just draw a really rough picture of what this looks like. What this means is that I have a y value that's negative. If I have a y value that's negative, I'm going to be either in the fourth quadrant or I'm going to be in the third quadrant. And I also have a y value that is positive. So really, there are a bunch of solution options here. I could be negative in this quadrant here. I could also be negative in this quadrant here, and that could be the negative 2.186. I could also be positive, which is the 0.68, and that could happen here, and it could happen here. Note that y is going to be positive in these areas. All right, so what I want to do is I just want to go ahead and solve and see what I get. So in my calculator, I'm going to go ahead and evaluate cosecant of negative 2.186. So to evaluate this, I'm actually going to write it in terms of its reciprocal. So this is the same thing as me saying, hey, what's the sine? Sine of x is equal to 1 over negative 2.186. And this is the same thing as me saying sine of 1 over 0.686. In fact, we're going to be pretty happy about what happens in the next couple steps here. It's going to save us some time. All right, so if I evaluate both of them, if I take the arc sine of 1 over 0.686, I'm actually going to get something that doesn't exist. And the reason it doesn't exist is it's a number that's bigger than 1. And sine cannot have an output that's bigger than 1. So thankfully for us, that one does not happen. If I evaluate the arc sine of 1 over negative 2.186, I'm going to get this, negative 0.475. I'm going to get negative 0.475. So remember that this value right here, this value is an angle measure. It's an angle measure. So what I'm going to do is I'm going to graph that on my unit circle. I'm going to graph that on my unit circle. So if I go down negative 0.475 radians, if I go down negative 0.475 radians, that might look something like this. So if I go down negative 0.475 radians, that might look something like this. And that is going to be one of my solutions. The only problem is I know that I have a y value that's going to be the exact same. If I think about, say this y value was, for example, maybe it was just like negative a half. I know over here, the y value over here is also going to be negative a half, so there has to be two counterparts here. So the only other thing I need to do is figure out what must this angle be. So the only other thing I need to do is figure out what must this angle be here. Well, this angle is going to be pi, right? It's a whole 180 degrees. plus the remainder, which is 0.475. And so my other x value is going to be 0.475 plus pi. So if I say 0.475 plus pi, I am going to get, I think, like 3.617. We'll just add it real quick. So 0.475 plus pi. And I know you guys can't see my calculator. I'm sorry about that. So pi plus 0.475. And I get 3.616. So I get 3.616. 3.616. All right, so the only other thing I really need to do here, guys, is I didn't see any parameters on this question, so I just need to write it generically. To write it generically, I just need to add the period times n. So what I'm going to say here, in fact, I'll write it over here. The total answer is going to be my first solution, which is negative 0.475 plus 2 pi n. And it's also going to be 3.616 plus 2 pi n. Now you'll probably see, like in WebAssign, they won't accept negative 0.475. That makes sense because maybe they want to have their solutions to be uniform. You could also add 2 pi to this last expression here. If I add 2 pi to this last expression here, the official answer that you might see like on a WebAssign, or like if I asked you for extra credit to write it as such, it would be 2 pi. Yeah, 5.808. So 5.808 plus 2 pi n would be like the WebAssign official answer. So if I want to highlight all of the things WebAssign would accept, that is the answers that it would accept. All right, so I know that there is a ton going on here, but thankfully for us, we are online learning. So I'm going to go ahead and show you now how to do this on Desmos. I'm going to show you how to do this on Desmos now. Okay, so we're back. So on Desmos here, what we're going to do is we're going to type in the actual function. So the actual function that we were given was 2 cotangent squared x, and I'm starting off just from the beginning. 2 cotangent squared x plus 3 cosecant x, and we want to say, I guess we're going to move everything over minus 1. So really what I'm looking for is where does my function cross the x-axis? And I can see that happens at 3.167, happens at 5.808. And if you notice here, guys, I think our answer was 3.616, and the reason it is 3.617 on Desmos is because it rounded up. I think the following decimal was a 5. Note here how the only answers I'm really looking at, if I want to represent my answer generically, is I only want to look at the answers from 0 to 2 pi. The reason I want to do that is anything after 0 to 2 pi is just going to be a repeat. So I'm just going to look at the answers from 0 to 2 pi. In fact, I'm going to copy and paste these over, and then I'm just going to write them generically. So honestly, the answer right here, just using Desmos, is going to be 3.617 plus 2 pi n, and it's going to be 5.808 plus 2 pi n. It is as easy as that. Unfortunately for you guys, I do want you guys to practice factoring and practice showing your work a little bit, so I might instruct you to get it all in terms of one trig function, and then you can verify using Desmos, but Desmos is a great tool here that's going to verify your answer like that. All right, so let's go and copy and paste that over. All right, so if I copy and paste this over, my results from Desmos, I'm just going to go ahead and write the answers generically. Now, once again, we're dealing with a sine and cosine kind of type graph, which means my period is 2 pi. So once again, the answers here are going to be 3.617 plus 2 pi n, which is the period times any integer n, and x is equal to 5.808 plus 2 pi n. So obviously you can see at this point that using Desmos is going to be so much easier. And yes, it will be, but unfortunately we won't always be online. So I do want to practice using both calculator and Desmos at the same time. All right, we're going to try one more question. I know that this is like really dragging on here. We're going to try one more question here. All right, so 4 cosine of 3x minus 1 is equal to 0. So what I want to do is I want to solve this. Now, this is a multiple angles equation, so we're going to do a little bit more. first thing, kind of obvious, I'm going to add 1 to both sides. So I get 4 cosine of 3x is equal to 1. I'm going to divide by 4 on both sides. So now I have cosine of 3x is equal to a fourth. Okay, so what I want to do here is I want to solve this using multiple angles. I don't know cosine of 3x, but I could solve for cosine of just normal x if I wanted to. Or at this point, I could just use my calculator. Sorry. I could just use my calculator. It's really up to you. But what I would probably do here is I'd probably just use my calculator and see where does cosine of 3x equal 4, a fourth. So in your calculators, I want you to go ahead and see if you can get some sort of value. You can use Desmos or you can use your calculator. Take a pause and see what you get. All right, so if you're taking the graphing calculator method, what you could really do is you could find out what 3x is equal to. So using inverse cosine, I could take the inverse cosine on both sides. So if I take the inverse cosine on both sides, what I'm going to end up with using my graphing calculator is that 3x is going to equal, and I think I wrote it down somewhere, 1.318. And I'll say it generically since they didn't give us any intervals, plus 2 pi n. All right, so all I really need to do here is divide by 3 on every single piece. And so what I'm going to get is that x is going to equal 0.439 plus 2 pi n over 3. But if I think about just the general nature of cosine, I should have 2 solutions here. In fact, think about it. Anytime I have like a cosine function, a sine function, I should have 2 solutions. And the reason being is if I get cosine being a fourth, so I get cosine being positive a fourth, and I know it's cosine of 3x technically, that really means that I have some sort of cosine value. I have some sort of value in the first quadrant. We'll say cosine is like something like a fourth. Well, cosine is also going to be something like a fourth all the way down here. And so what I got for my first value, is 1.38. So we're going to say that this angle here is 1.318. So I need to find what's this angle here. Well, this angle right here is also negative 1.318, but if I want to keep everything positive the way like Desmos likes to have it, really what I did here is I took 2 pi and I subtracted 1.318. It's the whole 2 pi minus 1.318. And so what I get here is 4.96, hopefully this is right, 965. So I also have that 3x is equal to 4.965 plus 2 pi n. So I'm going to go ahead and divide everything by 3. And what I end up getting is x is equal to 1.655 plus 2 pi n all over 3. And so those right there are my solutions using the graphing calculator and using a little bit of logic from the unit circle. So honestly, it's very rare that you're going to have one solution. In fact, the only cases I can think of when you have one solution, it would be like when sine x is equal to -1. That only happens once. Or like when cosine x is equal to +1. That also only happens once. All right, so let me show you how to get this on Desmos next, and that'll be the last thing we do. Okay, so we should be on Desmos at this point. So what I'm going to do is I'm going to type in the actual equation here. I'm going to type in cosine of 3x. It's 4 cosine, my bad. 4 cosine of 3x minus 1 is equal to 0. And so I want to know, where does this cross? Where is it crossing the x-axis? Okay, so I'm getting 0.439 and I'm getting 1.655, which are the answers that I have. Now here is where we really need to use our brains, because a lot of us are probably thinking, I think I'm just going to add, I'll just add 2 pi to both of these solutions. And that would actually be incorrect. We can't add 2 pi to both of these because the period is not 2 pi anymore. If I go back to my actual solution, the period was 2 pi over 3. So if you are going to use Desmos on these types of problems, you need to think critically about what the new period is going to be. And in this case, the new period is going to be 2 pi over 3 because I have that distortion of the 3x in the cosine. All right, so let's go ahead and put that into our solution. Okay, so I'm just going to go ahead and paste our information in here, and it should look like that. All right, so once again, this should match my general solution here, except I have a changed period. So instead of my period being 2 pi n, because of that 3x in the cosine, it's going to be 2 pi n all over 3. You might also see here that there were other solutions I didn't pick from. The reason I didn't pick those other solutions is they actually are duplicates. So they're going to actually kind of represent the exact same thing. And so I'm not actually going to represent them in my solution. All right, so that's really all I have for you guys today. So be practicing these, both using Desmos and using your calculator. I want to make sure that both of those skills are nice and fresh. All right, have an awesome day. I will see you tomorrow.